differences between,
That's great.
huh?
That's a pretty significant difference.
So,
Yeah, it's a really significant difference.
so I started a Stack Overflow question and then she answered it because I couldn't get someone else to answer it for me. But that was, if you have a case class where you have had an implicit companion object and you want to make an explicit companion object that looks just like the implicit one, what do you do?
Yeah.
And so so what you do is you extend function on the, and that sets it up. But then there's other conflicts like the stupid constructor thing, and that's when you have to turn the case class into abstract if you want to go further. It's a heady thing to go dig. It cost me only 50 hours.
Oh,
Yes.
okay, so what else is in our companion object?
The unapplies, or you?
So it really is treating it as an object, the same way that we saw with object main. There's a module
Yes.
dollar and a static new down here, so
Yep.
that's really crazy.
So that's your background pattern for a companion, an explicit companion object. No, just generically companion object.
Did it also define twice on the food class?
Yes.
Not the food, or
Yeah, so
Yes, it did
on
both.
both BAS, so here's twice on BAS, and then it defers off to BAS dollar.
oh, okay, yeah.
Which is all.
But that also has it, so.
But that one's not
That
static.
one's the
That's just
computation.
sitting on the one instance it generated.
Right, and so then in Scala land, when you call BAS dot twice. or
Capital
dot-
B BAS, not twice.
Right, which method are you calling off into?
This one.
You're calling off into this
That-
one,
yeah, that-
because
yes.
Scala knows that you're referencing a method that you've added.
Right. But if you have a
It's crazy.
lowercase b
But,
BAS, that you've created, in other words, you've created an instance of BAS called lowercase BAS, b BAS.
But then it
BAS,
won't let you call it, because it knows that that method is often in the companion.
But
You say it
Java-
won't, but I think it will.
no,
Like-
no. If you do BAS dot apply, open parentheses, it will call the one we're seeing over in the other place and forward it to here.
If you write your code in Java. If you write your code in Scala,
It knows.
guarantee it will not do
So
that.
you can't say val b baz open paren, so now you have a baz, and then
Oh,
you
well,
say
wait, did I?
b dot twice,
I'm
right?
pretty sure you can do it because I think I've done it. Yeah.
All right, let's see. Let's see if that compiles. So what you're saying is if I generate
That's what I was wondering, yes.
can I do that?
Well, you need to assign it to something, but yes. Well, technically you don't. It will just execute and you'll never see it.
Oh, let's see if it goes.
So your BAS with the constructor is not your object BAS.
Scala doesn't let you call static methods from an instance.
Right, basically. So you can do it from Java. Cannot do it
Okay,
from
got
Scala.
it. I got it.
Which is so weird, even though the code is there, it's just preventing you from doing that.
So
It's
technically
literally only
in-
there to make Java happy.
Right. In other words, in Scala land, if you looked at the tasty output, right? You look at that point, it's not
Well,
not
the
there.
is going to be something entirely
No,
different.
it's that abstract syntax tree. If you look at the abstract syntax tree before it gets flipped into Java, that doesn't exist
I
on
don't
the
know
Scala.
what they're capturing. is
class.
tasty.
Yeah. Yep. Okay.
Okay, so we're running into lots of interesting things, and we've only gotten through 2 of the modules, by the way.
Mm-hmm.
What other things do we have? Yeah, so that's a regular class and bar up here, which does not too crazy stuff. It looks like a Java, like we could write this as a Java class and it wouldn't be that bad. The case class stuff gives us a lot, and now we can finally see, like, if we had a case class of 15 things, yeah, this is going to be tremendously helpful because all these methods just get written and they do the right thing. So then even Scala gets fun when you have like overrides, because you drop drop your function stuff, which, yay.
That's really weird.
Well, but I remember Jim finding that, and I wanted to see like, okay, where does that actually appear?
He talked about it here about a year ago.
Yeah. And what's weird is it's your companion object that implements that trait, not your regular object. Why the hell is that? I mean, it sort of makes sense, I guess, because it's a function of your arguments to your baths. So I guess it has to live outside of that as a static method. It's going to live anywhere. But it could live, well, no, it would have to live here. It actually does have to live here. That's so crazy. All right, so who wants to look at one more module? And who wants to go home? All right. I will stop when people start walking in.
It's cooler than I thought it would
Do you have any scenarios where you are having to call Scala from Java
Yeah.
a lot?
I've only had to do it a couple of times, and it's always been, the only stuff I've ever had to actually deal with has been module dollar. It's like calling into those methods appropriately so that everything is actually set up. Because when I did it the first time, I got all kinds of NPEs, and it was really unhappy. So, this is honestly stuff that we've already looked at, so I don't think we're going to gain anything by looking at this. The only thing that we might possibly gain is by looking at how, that's why this was here, was how Scala does constructors differently, which we already covered. So fortunately, we can skip that module, because we've already seen that. The traits example I have isn't very good, and I'd like your guys' help making it better. So let's compile this code. So our one traits object, which actually contains a bunch of objects, generated all this stuff. So let's go see what's going on. Okay. Let's look at the code first. Actually, kind of a bit. So we've got a plain trait. We already know that traits can do things that Java classes and interfaces can't. Now that's less true today in terms of like default methods in Java 8, but Scala's had traits since the beginning, and these traits have been able to do these things without full-on JVM support. And we know for a fact that all the niftiness is coming in 2.12, and I'm only running 2.11 here. So we get to see how Scala used to do all this stuff, and then a little bit of how we know it's going to be changing. So we've got a trait named plain, and then we have a plain impl, which overrides and just returns us a string. So this should look the same as like I'm implementing an interface, and let's see if that's what Scala is giving us. I'm really hoping that that's what Scala is giving us. Okay, so we have a class plain, we implement impl, and it's an implement rather than extend, so we know that it's an interface in there. Our print returns print impl, which is what it has down there, so that's very simple. Okay, and this is just a standard, it's an abstract interface, which is kind of weird.
Yeah. What's the difference between an interface and an abstract interface?
I have no idea, I can't imagine they would be
The
different.
interface is something that can be implemented. You have to implement those methods. Abstract something override.
It's
But
true,
those
but
two sound like they're conflicting.
yeah.
You can't do
Why
that.
would you have an abstract, like, you
I don't
can't
believe
have-
that's valid. I
It's
don't,
not
I don't believe
valid
there,
Java.
that's not valid
Yeah,
Java.
you're right.
Yeah.
You can only have an interface, or you can have.
So that's just the
Crazy
decompiler.
code.
That's
Yeah,
just
this
the
might just
decompiler
be the
freakiness.
decompiler line to us.
Or Scala doing something that it knows it can do and screwing up the decompiler.
Yep.
Just do Java C on MC.
Yeah, I could. Let's look at complex and see what's happening when we do things that we know that we can't do in Java. Like, we know today that we can't actually have real code that does stuff in an interface today. We will be able to do it via default methods in Java 8. How are we doing this stuff today? And the other thing is, like, how do we handle lambdas? Like, what are lambdas really? Because, again, Java never had this and Scala always did. So what are we doing? So we have complex, which, again, looks very similar to plain. We have a print method up here. And then we have a complex impl, which does print of something, which is going to take the length of some string, and then actually just toString that. Ignore the logic. Let's just look at the tangled mess of how the functions are calling each other. Okay. So here's complex impl. Here's our class. Good. Thank God it's a class. He's implementing complex. So again, complex itself is going to be our interface, which is nice. But all of a sudden, we start to see a lot of the stuff that's up here is being brought down into here because it is an interface, so we have to be implementing those things, which makes sense. So here we have fields, though, that we're holding on to things. So that makes sense because our interfaces can't have fields, so that any fields declared in a trait are going to have to be moved down into a class that inherits them.
There's a
That
dot
makes
behind
sense.
random. Is the import showing that random has a
I
dot?
think this is going to be for this guy right here or something. We'll see why the decomp.
No, the import has got it as well. Scala util random dot up at the top.
That's the legal name.
Yeah, it must be.
It's probably random dollar.
Ah, okay.
Because it's probably a part of the companion. It's probably a part of an object or a companion class, and so that's why it's important.
I see. Okay.
All right, so here's our len. Here's our r. So what was r? R is a private val that is an instance of the random class. Okay, that makes sense. So that's what we're going to have down here. And then we've got a setter of len. What in the world is that? Interesting. So we've got a setter for something that's a val.
Well, it's a function. Oh, you're right. Why would they expose that? Huh.
And it's public.
So what calls that?
I don't know yet, but we'll find out. This is really weird. So we've got some string, which is right down here. Okay. But he's punting to this guy, our dot class, which is complex dollar class. Okay. So there's already, we can see lots of magic going on. Let's look at complex, which is the trait right here. So we know that if he's going to be an interface or anything close to an interface, he's got to look, well, something like this. Which this makes sense. This doesn't make sense to me yet. This doesn't make sense to me yet. But the rest of these sort of seem right. We have 1, 2, 3 things at least that we know that we need to be able to get as public methods. So print, len, and sum. Here we have print, len, and sum. And this guy is private, but we need to be able to get him anyway because interfaces can't have fields. So this is where Scala is going to protect us from ourselves, but if we were writing this against Java, we could do some very bad things.
We can look into Scala objects and classes in ways that you cannot from Scala.
Yeah.
Okay, that's what we're really exposing.
Yep.
Okay. Yeah.
Okay, so now there's 2 more things that we're seeing here that are going to get real fun. Complex dollar class, and Scala uses a lot of prefixes, so we know that complex and complex dollar stuff is all like grouped into whatever makes this trait a trait in Scala. So here's an abstract class. So Is there,
I think they're equality checks. Because if you look at the parameter, it's a function.
well, generally dollar equals is like a setter. It's an A equals something. Like that's what we saw with the var, right?
Yeah, no, that's right.
So this is where traits generate a synthetic class,
And it's synthetic abstract class.
which I didn't realize.
Yeah, me neither. But it makes sense because the implementation has to live somewhere.
Right.
Yeah.
And this is where it puts all of the implementations of the functions that we're actually putting in here.
Which then, Beck, you can't inherit from two abstract classes. So how does that work to pull all the implementation together?
Let's look.
I figured out why it has a setter though.
So we're calling len down in complex impl, right?
Yeah.
Well, where are we calling that? We're calling this, which we're
That's being
implementing.
set later on. Whenever the
Where's the call to complex setter len equal?
that's in the initializer for the synthetic class.
That would be, so we'd have to look at the bytecode. Yep.
It's
Yeah, you're not. That's right. It won't decompile.
the setters are there so that you can have the initializers in the body of the classes.
And they're public because they have to bridge between the two classes, right?
Something like that.
Well, in other words, there's more. They could have scoped it down to protected or package private, but that probably has other challenges to get around. Yeah, that trait's not in the same package with you, then you can't. It doesn't work. There.
Oh, no, actually, we just have a plain, this is totally removable. But this is not. Interesting. So I think this is where the whole trait linearization stuff comes from. Because I bet if we were inheriting from multiple traits,
Just have that a bunch of times.
we would have this a bunch of times for each of the
Oh,
traits.
what? It would invoke static on each one, and it would be
Yeah.
in the whatever the hell they call it when they did serialize the traits.
Linearization.
Linearization. Yep. Yep.
Okay, so now we understand how that works. That's bizarre. Okay, so let's look back over here.
You know, you can actually begin to see why Paul Phillips might have gone insane.
Yeah.
Oh yeah, totally.
Yeah. This man. Huh.
So I think it's SumString. I think SumString is the one that shows you how all of this is implemented. So SumString doesn't actually live down here, yet we're still able to reference it as a method up here. So what is the compiler doing to make this resolvable from our class? Well, this is where Scala knows about the magic of the extra shit that it's generating. Because look at where SumString is punting off to. Complex dollar class.
No dollar? Oh, is it the dot?
Yes, the dot equals
Okay.
dollar thing.
Gotcha.
Yep.
Yeah.
Uh-huh.
So it knows and it rewrites all of those accesses knowing, oh, you're going to live up in that trait, and I know it's going to have that synthetic class as a static method. Let me just rewrite that and pull it in.
And there's the init. We were wondering where the setters were at, right?
Well,
Yep.
what's
And this is it.
then I don't understand what's instantiating this so that you can get to it.
Oh, so
Where's the inheritance that causes this to
because
be
we're
concretized?
not inheriting. There's no actual
Right.
implementation.
But that's an abstract class, and you can't actually make that call
You don't need to.
because you are in a
Because you're-
public static.
Right,
Is that what
right.
you're a public static? I mean, you're a public abstract class, but because it's a static on it, there's no need to instantiate it.
Right. You
Wow,
don't
how
have to.
clever! That also blocks instantiation.
Yep.
That's the only.
I mean, it.
Technically, why didn't they do final public abstract class
Um,
to block the derivation? Well, it's
I know
okay.
what that means.
Well,
Like, is that
final,
even legal,
public, oh, you
John?
can't do final and abstract in the same field, that's why.
Yeah.
That's why they did that. Yep, okay. Very, very cool. Wow.
I mean, I would say it would be better to do final, but then that probably,
Now, why abstract?
yeah, why abstract and not final? There's probably a good reason for that. Like, does anybody ever have to inherit if you do if you do trait stacking? Like, I bet maybe
And I wonder
some of
if
these
there's
guys-
the other angle, and that is, what's the efficiency of execution and the JVM jitting it up, right? Is there any pathways there? they
Yeah,
had
because
to
the
evaluate
JVM
that.
isn't gonna know about this pattern.
Right. Yeah.
So it's like adding 2 layers of indirection for a single layer of indirection,
Yep.
basically.
Yeah, pretty much. So this init method is going to get called when we construct complex impl. So this is where everything is going to be set.
Fascinating. Uh-huh.
And then if we want to actually get some string, we can do it right
That's so clever. Wow.
here.
And I'm pretty sure they only do that init part so that you can have the body of your class have initial do things.
Because trait can have
Yeah, your
other-
body of your trait can
Yeah.
have executing code. Yes.
Yep. Which is so crazy.
I wonder if there's simpler ways to implement this.
But you could really screw with a Scala object by knowing that this stuff is here.
Yep.
So if you ever see anybody doing stuff that looks really weird, they probably shouldn't be.
You could like manually edit people's class files to really screw stuff up.
Oh, yeah. Well, that's always true. This is like a public method, though, that you can actually call into from Java.
But can you call into it from Java? Or will Java only let you call into things that are defined?
So I know
beforehand?
in Java, dollar is legal because module dollar exists and you can call into it. Pretty sure dollar in Scala is not, or something like that, and that's how
It is, but it screws up compilation. So
Oh,
there's
that's
strong
right.
recommendation to never use it,
That's
but they're
right.
not actually, they do not preclude it.
Dollar
Okay.
sign gets
It's
translated
legal,
to
but
dollar
not
sign
cool.
dollar. Like dollar
That's
sign
right.
and the
Yeah,
word
you
dollar.
could really.
Yes,
screw with
that's
this.
right. Yep,
Forgot
but they,
that, yeah.
when they said that, don't ever do that, you're getting yourself into a self-referential issue.
Yep. And now we understand why, because we're using dollar sign all over the place. So we actually don't have as many guardrails as we thought. That kind of sucks. All right.
Yeah.
So now we see how traits have like this synthetic class and static methods and all kinds of stuff.
Very clever.
What is this anon fun? So this is how we actually do lambdas often in Scala. That's what this guy is right here.
Well, technically
Is-
string, that's the profile of the lambda, and then
Right.
that's the implementation
Well, that's
on
the
the
type
right side.
signature. Here's the
Yep.
implementation.
Yep,
He's going to implement function 1 because he's going to take a string and return an int. But he needs to live someplace. It turns out that this is the synthetic class that we generate for all of the anonymous functions. The $1 indicating it's the first anonymous function in the trait class object, whatever. So if you have multiple, you'll have $2, $3, $4. Yay!
Until Scala 2.12.
Right, where a lot of this stuff becomes default methods. Or
Right,
and Sam screws with this too a little bit. Where the overloads aren't as pretty anymore because now the Java SAM inference, the single abstract method, a lot of those things become valid targets for lambdas. So now if you have a method of a function and something that could be a SAM, you have to distinguish between them. Which kind of sucks.
at the Java level.
At the Scala level, where you actually have to provide type annotations to tell Scala which function you're calling. Because your lambda might fit either profile.
Oh,
Because it will instantiate a SAM for you because you've handed it a lambda.
so, oh, this is in 2.12, so we don't have to worry about that in 2.11, it's only in 2.12.
There's probably going to be a lot of code that breaks because of this.
Wow.
Which, well, that's just the payment.
Well, if you want the efficiency though, you're gonna have to put up with the adaptation.
Yep.
Okay, got it.
All right. So this doesn't look that bad. Here's our apply. And we know that function implements apply. So, oh, and there's the outer. Okay.
Oh, which is a reference to the interface so it can get back into the function and make the call.
Well, it's so it can be a full closure. So that if it references variables like say,
Yes.
It's the scope.
it's the
basically.
scope.
So it doesn't actually capture the state of the variable at the time the function is instantiated. It's got to capture it at the time of the actual call to apply. And to do that, then you have to have a reference to the originating instance. I got it. Okay.
So this is
That's the mechanism. Very,
That's the
very
mechanism.
clever.
oh no, actually this. Yeah. It's the,
So if it was to, if we had actually referred to a public val, or even a private val up in there, we would actually see that referenced.
let's do that.
Plus, there it is. Awesome. Awesome.
That's really cool.
It is. Good suggestion for a topic. It is. That was a great suggestion.
So we're only about halfway through. It's 9 o'clock.
Oh.
Does anybody have questions or other stuff? I think we should go through like the other half.
I was just saying, you want to do it? Let's.
Well,
set up
not
the-
next time because we're going to have our Spark guy next time.
Yep.
So tell your friends we're going to have Paul Hargis talking to us about an introduction to Spark. So that's something really, really awesome to look forward to next time. But maybe in September, well, September will be really interesting for me.
Well, and actually, I've got, can't remember his name right. Vancy? I think it's Vancy. That's
right.
He said, I just answered on the thread, so if he
Yeah.
goes through that, then it'll be October.
Yeah.
And I can certainly, if you want to do that, I'll go ahead and put you down for October.
Yeah, sure, why not?
Okay.
It'll be a good reason to be out of the house. All right, so
You're October.
anybody have any questions, concerns, thoughts? I mean, you can start to see where interfacing from the Java side back into Scala, there's a lot to know, a lot of dark corners of things that are going on. You can be scratching your head just like, why the hell doesn't this work? Oh, it's because your outer pointer wasn't set. Oh, God.
Well, we were on Grok Scala on Monday night. It came up about having a mixed project, and my statement
Don't.
was, that was my first statement, don't. And then my second statement is, if you're going to do it, you're okay calling Scala into Java, just avoid calling Java into Scala, and you shouldn't do it. And if you're doing it, reconsider maybe another career.
Yeah. Don't do that.
Well, I think it's not bad if you just make like an interface or something with well-defined entry point. Don't just make arbitrary ad hoc calls in Scala.
Yeah, but
Like a facade in front of.
if someone's just starting out in Scala, I don't recommend them going anywhere near that space, just because it's so, when you listen to the Akka team and what they have, the hoops they have to leap over
Yeah, but
to
that's very
try.
tight, right? Java calling using Scala kind of stuff. I'm talking about, if you're writing new Scala code, you can write the bulk of your implementation in Scala, and then you have a few main like service entry points. that can be called from Scala.
You're right there.
That's no problem.
I think you'd still hit headaches, because if you're not, you still hit headaches, especially if you're using things like Scala option. But you're right. As long as it really is, you're minimizing the actual interface, then I think you're right.
So one of the bits of pain that I ran into in the past couple of days was between Jackson, type erasure, and Scala.
Huh.
So I have Jackson that's decompiling or deserializing everything, but into a Scala option. Now Jackson is really, let's say, intelligent, Because when it encounters a JSON number, it always encodes it as a double, which is appropriate behavior. That's absolutely what you're supposed to do. Fortunately, I wanted it as a float. And I told the annotation in like an option of float. That's what I wanted it as. That fails to compile. Well, it compiles, it fails at runtime.
Oh, okay.
Because of type erasure. It doesn't know that you want to deserialize it as a float. It just knows that it's an option. It's an option of something, and it's going to hand you back that number when it deserializes it. And then when you do the cast, you're casting it double to a float.
And that doesn't
And
work.
you fail.
Yeah.
So you actually have to annotate all of your things with, well, I can actually show you the code.
Can't you just map it at the very end and do underscore?
That's basic. Well, I sort of do that. It's actually, oh look, it's this code right here.
Literally the last thing you're working on, huh?
Yeah. It's this right here, where you have to call JSON deserialize,
Is there a reason you're using Jackson instead of the
because it's really fast.
compiled?
And it's literally a gigabyte of JSON.
Oh yeah. Okay.
So I need it to be fast.
I've asked you that before. I remember this.
Yeah. So the fun part comes in that this annotation works for option. What happens when you have map? Or option of map? Well, you're screwed. So if you're ever going to have an option of map, to have just, pull out the keys, because I know what the JSON object looks like, and your values are numbers, it has to be a double. You have no other option, and as far as I can tell, if you put JSON deserialize on there, it's going to have no idea what you're talking about.
Huh.
So,
Isn't float a synthetic subtype or whatever of double, or is it the other way around?
I mean, they're both type aliases in the Scala's boxing of these things, which then get unwrapped into. I think the boxes are different, and that's the issue.
Okay, yeah. Because they're both, map is covariant on the.
Yeah, because I don't think
outside
float
functions.
inherits from double.
It doesn't. Yeah, they will come from numeric, but neither come
Right.
from each other, yes.
And that's going to be the issue. So that'll be a class cast exception, which is what you get.
Yep. Suck.
But this is one of those things where, like, Java, Scala, you can run into these issues all over the place. All right.
Thank you, Mark.
Yeah,
That was
thank you.
awesome.
Very informative.
Yeah, awesome.
Oh, so what were the topics that we didn't actually get to?
What's next? Yeah.
There were quite a few, and there was one that I actually need to add to here. So we covered basically covered all of that.
We didn't do stack traits.
We didn't, and I need a better example of
Oh, okay,
traits.
all right.
We did some of this. We saw a plain object. We didn't see an object with trait.
Yeah.
But we can imagine how that would
Hit
be
pluses
generated.
on, just turn them into pluses on the ones you've done.
Yeah, that's a good idea.
Pattern matching would probably be interesting
So,
too. And Java equivalent.
That's exactly the notation I use when I'm doing this outline stuff.
okay, so we got through a lot of this. We didn't get through that.
Got that.
We never really looked at that.
We just sort of reviewed, yep. Didn't do that.
We definitely looked at this. Did not look at that. Okay.
Good.
So we got through a little more than half of it. which is
Did
good.
invariant, covariant, and contravariant even make it that far? Is it-
Yeah, that's what I was
I
wondering.
don't think they do, because I think the type systems are different, which is why you need Scala signature if you're ever doing anything with like real types.
Yeah.
Very informative. Awesome.